Welcome to this video on logarithmic functions, part 4. In the first video, we learned to convert between logarithms and exponents. In the second video, we learned how to evaluate logarithms and to use the ability to convert between logs and exponents in order to solve basic logarithmic equations. Then, in the third video, we became familiar with the common log and the natural log. In this video, we will learn how to graph logarithmic functions. Let's begin. Example, graph f of x equals log base 3 of x. So it's true that graphing calculators do have built-in logs, and you could use a graphing utility or maybe Desmos. You could use lots of different graphing utilities to create a graph of this function. Okay, but we're going to do this by hand without any assistance from technology. Well, how do we do this? Well, the first thing we're going to do is we're going to rewrite this in exponential form. Okay, so remember 3 is our base, right? X is our result. Okay, and y over here is our exponent. Okay, so what we need to do is we need to rewrite this as 3, right? Because 3 is our base, y is our exponent, okay, and x is our result. So we're going to have 3 to the y power equals x. So what we're going to do is we're actually going to sort of create one of those exponential number lines, right? And we're going to use the values on that number line to fill in some ordered pairs, and then we can graph the function. So let's begin. Step 2, create a table. We will choose the exponential form of the equation x equals 3 to the y to populate our graph. We will choose values of -2, -1, 0, 1, and 2 for y, and then use the exponential values to find x for these values of y. So you might be thinking, where the heck did these numbers come from, right? Well, let's just go back to our number line, right? So remember, usually when we have our logarithmic number line, we have 0, 1, 2, 3, 4, something like that, right? -1, -2, -3, right? And then we just remember we put our base down here, right? So our base in this case is 3. And 3 to the 0 power is 1, 3 to the first power is 3, 9, 27, so on, right? Then we have, of course, 1/3, 1/9, and 1/27. Okay, so if I had 3 to the x equals y, right, x, I would let it be, -2, -1, 0, 1, 2, right? I would just pick some convenient values and then, evaluate that. Okay, but this is a little bit different because why? Because these numbers here, right, are actually my y values, right? Because remember, your y value is your result over here, okay? So then my x values are these guys right here. So I'm going to treat this a little bit differently. I'm going to actually control y. I'm going to say, okay, let's pick these values of y because they're easy and simple and I can do them in my head. Okay, so I'm going to choose those values of y, and then I'm going to use the exponential form of the function to evaluate that. So let's go back to this chart and try that. Okay, so I'm going to start with y equals -2. So x is equal to 3 to the -2nd power. And if you're like, well, what the heck is that, right? Well, what is 3 to the -2nd power? It's right here, right? 3 to the -2nd power is 1/9. So this is going to be equal to 1/9. Right? Then we have x equals 3 to the -1st power. Well, go back to our chart. 3 to the -1st power is right here. That's 1/3. Right? And we can keep going with this pattern. 3 to the 0 power is 1. 3 to the 1st power is, 3. And 3 to the 2nd power is 9. Okay, so we have ourselves a nice set of ordered pairs that we can graph. Okay, so when x is equal to 1/9, gee golly, where is that? Well, here's our x-axis, here's our y-axis, right? So I'm going to assume that each of these tick marks are 1 unit. So this will be 2, 4, 6, 8. I'm only labeling every other one just to make it more visually appealing, not for any mathematical reason. Okay, so if this is 1, where the heck is 1/9? Well, isn't that almost at 0? It's just a tiny bit over, right? So when x is equal to 1/9, y is equal to -2. So that's like right there. Okay. When x is 1/3, that's like maybe right there. Y equals -1. So that's going to be like right here. Okay, when x is equal to 1, that's right here. When x equals 1, y equals 0. So let me put these in a different color so they're much more obvious and they stand out better. So here we go. Okay, then we have a point there. Okay, then we have a point 3, 1. That's right here. Then we have a point 9, 2. That's right there. So we actually have enough points to fill in or to kind of sketch our curve. So let's go ahead and do that. Okay, and what we're going to see is we have this behavior very similar to what we saw in the last section, where we can get arbitrarily close to the y-axis, right? But we never actually touch it. And this behavior right here, and we'll learn, you don't need to know that for this test, but in another course you'll probably have to know this. This is called a vertical asymptote. Okay, so a vertical asymptote, the behavior of the graph is that it gets arbitrarily close to the y-axis, but it can never touch it, and it can certainly never cross the y-axis. Okay, all right, let's do another example to get more comfortable with this process. So this one says graph f of x equals the log base 2 of x. Okay, so again, we're going to take y equals log base 2 of x and we're going to rewrite it in exponential form. So remember, our base is 2, so we're going to write 2. Our exponent is y, so we have 2 to the y power, and our result is x, so we have 2 to the y power equals x. Okay, so if I were to create a nice little number line, right, a logarithmic scale here for myself, well, I would go 0, 1, 2, negative 1, negative 2, right, and then I put my 2's in here. So 2 to the 0 power is 1, 2 to the first power is 2, 4, 1/2, 1/4. Okay, and that's probably enough numbers to create enough ordered pairs for my graph. So let's go ahead and go to the next slide. Okay, so again, we're going to use those values of y that I just showed you on the number line, right, to fill in this table. Okay, so if y is negative 2, then x is equal to 2 to the negative 2, or 1/4. Again, go back to your table, right? 2 to the negative second power is 1/4. Okay, then we have 2 to the negative first power. Well, that's 1/2. 2 to the 0 power is 1. 2 to the first power is 2. 2 to the fourth power is 4. Okay, so again, I'll try to pick a different color here. So we're going to assume that each block is a scale of 1. So this is 2, 4, 6, 8. 2, 4, 6, 8. Again, this is the x-axis, this is the y-axis. So where is x equals 1/4? Well, if this is x equals 1, right, then it would be 1/4 of the distance to 1. So maybe right about there. Okay? So when x equals 1/4, y equals negative 2. So that's right about here. Okay, then when x equals 1/2, y is negative 1. And then when x equals 1, y equals 0. Okay? Then when x equals 2, y is 1. And when x equals 4, y equals 2. Okay, and we have a little bit of room. We could also say, if we wanted to, also I just realized I wrote 2 to the 4th power here. Let me fix that, please. Sorry, 2 squared is 4. I think I was thinking about the 4 too early. 2 squared equals 4. If we want one more point here, we could do 2 to the 3rd power equals 8, just to get one more point on this graph. So, yeah, so when x is equal to 3, when x is equal to 3, no, I'm sorry, when x equals 8, y equals 3. So x equals 8, y equals 3. So that's this point right here. Okay? All right, so let's go ahead and connect these points. Okay, and again, I just want to remind you, the behavior of this graph is what's called a vertical asymptote. Okay, it can get arbitrarily close to the y-axis. It's never going to touch the y-axis, and it's never going to cross the y-axis. Okay, so that is my graph there. All right, last but not least, we have graph the function f of x equals log base 3 of x minus 1. Okay, so again, I'm going to go through and identify my base, my exponent, and my argument, or my result, and then convert it to exponential form. So my base is 3, so I write 3. My exponent is y, so I write y. And then my result, or my argument, is x minus 1. Okay, So here what we need to do is we actually need to do a little bit of work. We're going to add 1 to both sides of the equation. So we're going to have 3 to the y power plus 1 is equal to x. Okay? And believe it or not, that's going to be quite helpful to us. Okay? And the reason that's helpful to us is because we're still going to use a base 3 scale, right? So, we'll have like 3 to the 0 power is 1, 3 to the first power is 3, 3 to the second power is 9, 3 to the negative first power is 1/3, and so on and so forth, right? But what are we going to do with all those numbers after we get them? Well, we're going to add 1 to all those numbers. So let's get started. Okay, so again, I've already chosen my y values here, right? -2, -1, 0, 1, 2. Okay, so let's get cracking. So this x value is 3 to the negative second power plus 1. Well, what is that? Well, that's 1/9 plus 1, so that's 10 over 9. Okay, then I have 3 to the negative first power plus 1. Well, that's 1/3 plus 1, or 4/3. Then I have 3 to the 0 power plus 1. Well, that's 1 plus 1, or 2. Then I have 3 to the first power plus 1, which of course is 3 plus 1, or 4. Then I have 3 squared plus 1, which is 9 plus 1, or 10. Okay. So now we have to graph this. Again, this is the x-axis, this is the y-axis. We'll assume that each little square is size 1. Okay, 2, 4, 6, 8. Okay. So where is 10/9? So if you think about 10/9, that's 1 and 1/9, right? That's literally how we got 10/9, is by adding 1 to 1. By adding 1/9 to 1. Okay? So where is that? Well, here's 1, right? So 1 and 1/9 is just a little bit to the right of that. Okay? So when y is -2, okay, our x is like right there. Okay? Then we have 4/3. Well, where's 4/3? Well, isn't it just 1 and 1/3, right? That's how we got 4/3, is by adding 1/3 to 1. So when x is 4/3, so 1 and 1/3, our y is -1. Okay? Then we have the point 2, 0. It's a lot easier to graph, right? Then we have the point 4, 1, and then we have the point 10, 2. Okay. So does this guy have a vertical asymptote? Can you tell? It actually does, but this time the vertical asymptote isn't the y-axis. It's actually the line x equals 1. Okay, and the reason that that's our vertical asymptote is because of this plus 1 here. We effectively shifted this graph to the right 1 unit. Okay, so that is the graph of x equals 3 to the y power plus 1.